Greetings everybody, how you doing? This is Kinesiology 231 and this video will be specific to our laboratory assignments where we're talking about body composition. And I wanted to take a moment to just go over these tables that are in the book. They start on page 249, they go 250, 251, because it could be almost like a wall of information coming at you, and it could be a little bit overwhelming. And I just wanted to take a few moments to kind of clear the air on what we're looking at here. So we look at table 11.8. 11.8 is on page 249, and there were different studies that were done, and these studies can be found down here, 1, 2, 3, and number 4, whether it's Jackson, Pollock, Evans, or Slaughter. And it's a way to further subcategorize the populations in terms of body composition. So when we look at these different populations here, you have people who might be black men or male athletes, 18 to 61, female athletes, 18 to 29, white or anorexic, et cetera, et cetera. You have the corresponding skin fold sites that are used to test those populations, and then you have the equations that you use to come up with body density being grams per cubic centimeter. That's what that G times CC minus 1 is. That's grams per cubic centimeter. So here's the deal. When you look at this, and if you so choose, you can further subcategorize this, where maybe you're a college level strength and conditioning coach, and as a college level strength and conditioning coach, you're working with women's basketball. And with women's basketball, we would end up doing the sum of 4 skin folds of tricep and anterior suprailiac, the abdomen, and the thigh, and the sum of those numbers would be fit into this equation here. So you can go ahead and plug and chug. You can see here, multiply 0.000011 by sum of 4 skin folds squared. And so it just depends upon the population you're working with, how you can further categorize and even further evaluate the people you're working with. Now for our labs and what we're doing for this class, you won't have to worry about this, but I just wanted to point this out that this is a table that you would use, and those are some of the formulas you would use. If we go ahead and go to table number 11.9, another way to further subcategorize is seen here. And we can look at like different populations, and then from that you can have different subcategories within those populations by age group, and then even further subcategorizations yet again by sex, male or female, and then you have the corresponding percent body fat equations that are used when you have your body density number. If we take this a little bit further down, you can see they even subcategorize out for resistance trained males and females, also endurance trained males and females, and then all sports 18 to 22. And I have to admit, I don't know why it's written this way, but you can see, like for example, resistance trained at 24 years old, plus or minus 4. So 1 standard deviation to the right and to the left of 4 years. Whereas down here for all sports, it's just in a broad age group of 18 to 22. Uncertain why they did it that way, but that's just the way they did it. If we go ahead and really look at what you really need to evaluate for this lab, we get into table 1110. In table 1110, you have 2 main broad-based categories. One at the top, you have male rating for criterion-based scores, and then you have normative references. If we look a little further down, you have very much the same except for females, criterion scores and female percentiles or normative references. If we just take a look up top, let's go ahead and look at male rating, and let's just presume you have a 50-year-old person, male, who has an 18% body fat. Well, they would fall in this category right here, and that score and value would equate out to a very lean or low body fat percentage. But notice what happens if the person is maybe 22 years old and they're at 18%. It puts them on the threshold of being fatter than average and even fat. So age kind of matters here, and you have to make sure you have that in your equations for when we talk body density and we use our skin fold caliper measurements. What the table is below that is this. If we look at it and go, okay, our same 50-year-old man is at 18%, that tells you they would fall at roughly 85% percentile, meaning that their body fat or body composition is better than 85% of the other people, other males within that age group. Same holds true down here for females. If we had 18 as our body composition for a 50-year-old female, notice it goes to very lean. So it changes based upon the sex. Same thing here. If we had 18 for 50 to 59, that puts us in the 90th Probably 90 something percentile, 93rd, 94 percentile. So just when we do our labs in class and you do the virtual labs, realize you're going to be referencing back to this area, but focusing on table 11.10. This is really what you're going to focus on more than anything else. And really, you're going to focus on either the criterion scores for men or the criterion scores for women as you evaluate your classmates for our laboratory assignment. So with that, guys, I'm going to sign off here and move on to my next presentation. But as always, you can always send me an email if you ever have any questions. Thank you so much.